All right, we just finished talking about how to solve inequalities and multi-step inequalities. We're going to take a look at what are known as compound inequalities. It deals with what you've learned about the word compound. It means more than one. Okay, you've learned compound words in English class, hopefully, and we'll take a look at how we solve compound inequalities. So let's get going with the examples. Okay, first example, we have x is greater than 3 and x is less than or equal to 6. So in that case, we take a look at this inequality. X is greater than, so it doesn't include that negative 3. Which values are greater than negative 3? I compare 0, that's an easy one to compare with. Is 0 greater than negative 3? Yes, it is. So my solutions will be going that way. The second inequality in this statement says x is less or equal to 6. So it can be equal to 6. Values are less. So if I compare with 0 again, is 0 less or equal to 6? Yes, it is. So my solutions go that way. So in order to meet both qualifications, I know I've got to have a value that is greater than negative 3, but is also less or equal to 6. So it can be any value in between there. Okay, so it's got two parameters now to keep in mind. And the way that we typically write that is down here. The compound inequality, so we've got this first inequality. Negative 3 is less than x, or the way we've written it up here, x is greater than negative 3. We can always flip around inequalities. So if I flip this whole thing around, notice the x goes second, negative 3 goes at the beginning, I flip that sign around. And I just take that one and write it down there. We've also got this second inequality. X is also less or equal to 6. Same one that we have here. So we just combine those into one. And if we flip it, usually the smaller numbers at the beginning, bigger numbers at the end typically. And if it's meeting both criteria, that variable will be in between. So we write that one just like this. It's greater than negative 3, but less than or equal to 6. So that's an and inequality. It meets both criteria. Okay. The one at the bottom is an or. Okay. Either x is less than negative 1. Compare with 0. Is 0 less than negative 1? No. So solutions go that way. Or I can say x is greater than or equal to 4. Okay. In that case, it could be equal to 4. If I compare with 0, 0 is greater than or equal to 4? No, that is false. So my solutions go that way. So I've got two possibilities. Either it's below negative 1 or greater or equal to 4. So these or inequalities, it can be one or the other. Whereas the and inequality, compound inequality, has got to meet both criteria. It's going to be between values. Okay? Whereas these ones will be beyond 2 points. Okay? So let's apply that here. So let's write the verbal sentence out. Let's practice putting words down as an inequality. And let's solve and graph it. So 5 more than x, 5 more than x, 5 plus x, or a better way to write it would be x plus 5, because it's more than x, is less than 8. Okay? Or, see a key word in there, 3 less than x is greater than 5. So 3 less than x is greater than 5. Okay, so we'd solve both inequalities. X is less than 3, or x is greater than 8. So this is an or, so the values will be beyond 2 points. So if I have 3 here, I know it can't be equal, but it will be less than 3. And the dividing point here is 8. The values are greater than 8. 9 is greater than 8. So notice my or has those two values there. Okay, two separations. Why don't you try that second example there? Pause it and check in when you're ready. Okay, so the way to write it, we take our words. 3 less than x is greater than negative 4. 3 less than x is greater than negative 4. And less than negative 1. Well, what's less than negative 1? That is the same expression. So 3 less than x is less than negative 1. So if it's an and, we can combine it into one by flipping this one over. So we say instead of x minus 3 is greater than negative 4, we flip it and say negative 4 is less than x minus 3. Because we can just say that x minus 3 is then less than negative 1. Okay, typically those inequalities will be less thans or less than or equal to's. Okay, so then to get x by itself, we have to add 3. So notice we have two separate inequalities. I've got this one. So what I do to the right side, I've got to do to the left side. But we also have an inequality that we've combined on the right. So if I add 3 here, I've also got to add 3 to this side as well. So when I do that, I get 2, cancels out just an x, and I get a negative 1. Notice the inequalities don't get flipped around because we're just adding. So negative 1 is less than x, less than 2. Means the values of x are between these two boundaries, negative 1 and 2. It doesn't include those because they're not also equal. Okay? So let's practice solving these. So I need to get m by itself, so divide by negative 4. Since I have to do that in one side of the equation, do it to the other. Since it's multiple equations, I have to do the same to the other side as well. So negative 1 divided by negative 4 is positive 1/4. Notice I'm dividing by a negative, so I have to reverse the inequality. Cancels out in the middle. And 16 divided by negative 4 is negative 4. And once again, we divided by negative, so flip that inequality around. Okay? You can rewrite it by flipping it all around if you'd like. We said typically we like to have the less thans first. We could flip this whole expression around. You don't have to. But then we have the values of m are greater than or equal to 4, but also less or equal to 1/4. So I can put 1/4 about right here, which means this will be 0, negative 1, negative 2. And those values will be bookended at 1/4 and negative 4, and it could be any solution in between there. Okay? Why don't you pause that and try the next example. Okay, so I distributed first, and then once I had distributed, I got this inequality. So I added 10 to get the p variable by itself. So I got negative 5 less or equal to 15, p less than 30. With the p by itself, I divide by 15. So I get negative 1/3. This cancels out, so I get p, and 30 divided by 15 is 2. Notice why didn't I flip the inequalities? Because I'm dividing by a positive number. So I have negative 1/3 is less or equal to p, which is less than 2. So I see that this is the dividing point at 2. It's not also equal. Then I want to make sure I have the dot at negative 1/3 because it also includes that point. Okay? Let's try some examples here using the OR. OR, remember, those would be the beyond ones. Okay? But we need to solve both of them. So get r by itself, subtract 3. 2r is less than 4. Then divide both sides by 2. We're dividing by a positive, so that sign doesn't get flipped around. So r is less than 2, or subtract 9. Negative r is less than negative 7. Divide by negative 1. It's negative 1 times r. So when we're dividing by negative, that sign needs to get flipped, and we get a positive 7. So r is less than 2, or r is greater or equal to 7. Okay, so on the number line, 1, 2, 3, 4, 5, 6. The values of r are less than 2, or the values of r are greater than or equal to 7. Why don't you try the next example, pause the video, and start it up again when you're ready. Okay, so as you can see, we had the compound inequality, the OR inequality, so we solved the one on the left. Subtract 13 from both sides, v is less than negative 5. And the one on the right, negative 8v is less than negative 40. Divide both sides by negative 8 to get v alone. Notice when we're dividing both sides by negative, we reverse the inequality. So v is greater than 5. We've got the solutions graphed out there. Okay, so we've learned what a compound inequality is and how we write them. Then we've also taken a look at how to solve those compound inequalities and graph their solutions. You got practice problems and application. We'll see you, and any questions you have in the next video.